In this video, we're going to be talking about the most common function graphs we're going to be looking at, and then eventually the characteristics of these types of graphs. So take a few seconds, copy down these graphs, and then we'll walk through the domain and range. So, domain and range of these graphs. The domain is the possible x values. So when I'm talking about the domain, I'm talking about how far to the left and how far to the right it goes. Well, these arrows imply that it goes on forever. So we're going forever in the left direction, which is going to be negative infinity. And then we're going forever in the positive direction, which is just going to be positive infinity. And the range is possible y values, so how far up and how far down. So going forever in the up and forever in the down, so the range is going to be very similar. Okay. Now there's different ways to write the domain or range. You can write interval notation or symbol notation. Either way, let's just stick with interval notation right now. Quadratic equations. When you have y equals ax squared, all the graphs will look pretty much the same, depending on what numbers are in there or how many operations. Even if it's even, or if it's like to the fourth, you'll see a U shape of the graph. So the domain is possible x values, how far to the left and how far to the right. Now in this case, it goes to the left all the way to negative infinity, and then to the right all the way to positive infinity. The range is how far down it goes. How far down it goes. Oh, it looks like it turns right at 0. And then goes all the way up to positive infinity. Now for the cubic, I think we're starting to get the picture here. Cubic goes all the way to the left, and all the way to the right, and goes all the way down, and all the way up. Now square root, this is where it starts to get a little iffy. It doesn't go all the way to the left because it stops right about here, right about when x is 0. So that's going to be your domain. It's going to be 0 all the way up to positive infinity. And the range, it doesn't go down all the way, it just goes down to 0, and it goes all the way up to infinity. Alright, now the reason behind these brackets and parentheses deals with a different lesson. So if you have questions about that, I can make a supplemental video, but for now, we're just going to keep on moving. For the cubic, we got domain, how far to left and right. Looking at these arrows, pretty telltailing. It goes all the way to the left, all the way to the right. And the range, how far up and down. Okay, so you see these domain ranges repeat a lot. It's just when you see turns or sharp curves or stoppage points is when they change. So here, for the absolute value, we have a turning point. So that's going to change our range a little bit. So our domain, how far to left and right, it goes all the way to the left and all the way to the right. And our range, it goes all the way down to 0, then up to infinity. And last but not least, our inverse function. It goes all the way to the left, and all the way to the right, and all the way down, and all the way and all the way up. But if you look at the graph, you'll see that they don't cross the origin at all. So x will never equal 0, and y will never equal 0. Okay. So those are the basic domain and ranges of the most common graphs. Again, these will change after some transformations are done to them, but for a starting point, it's not bad. Okay, looking at these graphs above, you might notice that several of these graphs have the same characteristics. For example, the quadratic, also the absolute value. Both of these are symmetric across the y-axis or the vertical axis, where the other ones are either symmetric across the origin or neither. So for example, the linear function is symmetric across the origin. That means it's a mirrored image across this point. So this is, if you flip this over on itself, it will match. Same thing for this over here, with the cube root function, and also the cubic, and the inverse function. They share the same characteristics with each other. So the quadratic and the absolute value share characteristics. They're symmetric across the y-axis. The linear, cubic, cube root, the cubic and the inverse functions share the fact that they're symmetric across the origin. Just flipping over the origin. And the square root is not symmetric over anything. So this will be summarized in the next slide. Okay, as promised, here's the summation of even and odd functions. So basically, even functions are symmetric over the y-axis, and odd functions are symmetric over the origin. The way to test that is, if we replaced the x and the f of x with a negative x, and it came out to be f of x again, it's even. And it pops out negative f of x, it's odd. So let's test this one right here. We're given f of x equals x squared minus 3. So we're going to try and replace x with negative x and see what happens. Okay, negative x squared is going to be x squared. And we can't simplify any farther, so x squared minus 3 is our answer. Well, that turns out to be the same thing as x squared minus 3. So f of negative x is equal to x squared minus 3, which is equal to f of x. So this is even. Let's try a different one. Let's try f of x equals x to the 5th plus x to the 3rd. Now if we were to test this, we would do f of negative x and plug it in. Simplify. Now we want to see if we can, well, I know it's not going to be equal to x to the 5th plus x to the 3rd, so I know it's not even. Now we want to see if it can be equal to negative f of x. Well, if I factored out negative 1 to both these terms, well, that looks like we just did. X to the 5th plus x to the 3rd is our original f of x. And we got negative of f of x. So therefore, it is odd. After watching those clips, you should feel comfortable, or at least feel comfortable to attempt these problems. Your job is to determine if they're even, odd, or neither. Again, keep in mind what even and odd means. Take a look at that table again. Look at your textbook if need be. I just want you to work on it.